So before we dive into working with and manipulating numbers, let's make sure we have a good understanding of the structure of the number system we use. In this video, I'm going to talk about the set of real numbers. This is the set of numbers that you have been learning about and using for pretty much your whole life. Any number in the real number system can be plotted in a number line. It doesn't need to be a number that is represented on this scale here, but it can be anything in between them as well. So let's take a look at the subset of numbers within the real number system and make sure you are aware of their names and what is contained within them. So the real number system has four main subsets of numbers within it. Natural numbers are the most basic. These are numbers that Elmo taught you, like 0, 1, 2, 3, 4. They are numbers you have been using and communicating with since you were a toddler. Integers are numbers that you were introduced to probably in the 5th grade, maybe earlier, but they include all the natural numbers, but also negative numbers. So we're talking about -1, -2, -3, -4, etc., and also 0, 1, 2, 3, 4, so also those natural numbers. Rational numbers are numbers that you've been working with for quite a while as well. Rational numbers include natural and integers, but also include any fractional number or repeating or terminating decimal. These are numbers like 0.25, 0.4 repeating, or -1/5. The last subset of real numbers are irrational numbers. Basically, irrational numbers are not rational numbers. So all the numbers I've talked about so far are rational numbers. They may also fit into the natural or integer category as well. But irrational numbers are numbers that can't be put into those categories. They are numbers that, when put into decimal form, never repeat and never terminate. Numbers like pi or the square root of 2 are irrational numbers. Let's look a little deeper into these numbers. So each subset of numbers has a symbol or notation that is often used to represent them, basically because mathematicians are lazy and they don't want to write out the whole word. So the letter N right here is used to represent natural numbers. Remember, natural numbers are numbers like 0, 1, 2, 3, 4, but it also goes on until positive infinity. There are no negative natural numbers. Natural numbers start at 0 and then they go up. The letter Z is used to represent integers. Integers include the natural numbers 0, 1, 2, 3, 4, like until infinity, but then they also include negative numbers like -1, -2, -3, -4, and that goes until negative infinity. There are no decimals that are integers and no fractions that are integers. The letter Q is used to represent rational numbers. And I think this letter Q comes from quotient, so we're talking about fractions here. So remember, rational numbers contain integers and natural numbers, so we're still talking about 0, 1, 2, 3, and then also the negatives, -1, -2, etc. But it's also numbers in between there, like 1/2 or 1.75 or even 2.5555. So rational numbers are any numbers that can be put into a fraction or have repeating decimals or terminating decimals. And what I mean by terminating is the decimals end. And then for irrational numbers, we use the letter Q again, but we have this kind of like not, like an apostrophe. So that means it's a number that's not rational. And those are numbers that, when put into a decimal, never repeat and never terminate. So we're talking about the number, the square root of 2, or the square root of 7, or 3 times the square root of 5, or even pi. 2 pi, 3 pi, maybe like pi over 2. These are numbers that if you put into your calculator, they are never going to repeat and they're going to go on and on and on forever. The last thing I want to mention is that real numbers, just the main category real numbers, that is represented by the letter R, and so you'll see it represented like that. So that is it for this video. Have a great one and let me know if you have any questions. Thanks.